So I bought a new computer so I could run Fusion by AutoCAD and have a CAM program. So when I get a CNC machine, that would work with that too. And also for this video software edit and stuff from DaVinci Resolve, which is a behemoth of a program, but really good. Anyways, saying that, here I am once again drawing sketches on a piece of paper. Nonetheless, what I decided to build, being that my milling machine is still down, is a follower for a tap. And I got to say, it's a good little milling machine, but it's not designed for anything above hobby use. I just cooked the motor in that thing, for continuous use on it. The motor is currently sitting in customs, and hopefully I'll get it back soon. And I've made the decision to use the money I've been spending up on my 5-axis CNC to buy an email and hopefully get a couple $1,000s off this machine I currently have. Anyways, with all my projects now, I'm actually going to be putting cutting speeds down and start getting in time in that, and being used to running the formula, which is pi times diameter times revolutions per minute divided by 12. And the reason I decided to do this is these videos are to help me with my apprenticeship. And right now, the part of my brain that likes to keep that kind of information in it is on holidays. So I just got to keep practicing, and repeating it. And every time I do those operations is to go through the math and get it to the point where it's just second nature to me. So for this project, uh, like I said, my milling machine's down. However, there is a couple projects on a lathe and some other stuff that I do want to be doing, and I also started doing some TIG welding too in the meantime while waiting for the motor. Um, though I do have to say, I remember myself being a much better welder than I currently am. there, there was a lot to use improvement on for the first welds I did there. However, though, I did get a bead at the end of the day, and I think one of the problems is it's a little wide or a little thick on the material, and the amperage isn't great enough on the machine. And at one point my machine jumped over to DC, and I just cooked the tungsten on it. Nonetheless, back to this project. I'm going to do the uh, the cut and speed for both the outside of the tool, and also for the pin on the inside of the tool as well. And like I said, just need more practice. So again, cut and speed pi times diameter times revolutions per minute divided by 12 for the imperial measurement on it. Um, I don't use metric. However, I'm going to have to start doing the metric math too, because I know on my first year test, that was one of the questions. It was in metric, and I was like, oh no, I got no idea what the conversion here is. And needless to say, I know I didn't get it right. So all this tooling is going to be done out of 4140 steel. I like working with 4140. Supposedly a mild to medium carbon steel, but it does turn very nice. And unfortunately, I cannot get it anything but round from the place I buy my metal at. Though I am looking for other sources to get steel from. I was also like to try some tool and steel, but the place I get my metal at, it's far and few between on that. So, the first thing I got going here is I got a project in the 4-jaw chuck, and I figured it'd just be easier to take that chuck out and put the 6-jaw chuck in there, and leave that project so it's uh, good to go. And I don't know what I did with the piece of plywood that I usually put over on the bottom of the lathe there, but I couldn't find it, so I had to put a couple of 2x4s down. And of course, starting this thing off, first thing I want to do is make sure that end is nice and flush, and then come in and put a little bit of chamfer on it, and from there and got to get it cut down. And the chamfer is just so, don't accidentally run my hand on it when I'm cutting it. It's way over spec on it at the time being. But my luck, if I didn't put it on there, I would have cut it. So, from there, center drilling it, getting it ready to actually put a drill in. And on this project, it does get drilled. I really made a huge mistake on the start of this project. And I'm going to put a cap screw in there, and I only drilled it out for maybe a half inch larger hole for that cap screw when it goes in, and it had to get drilled almost to the very bottom for that plunger on the pin. Needless to say, I had to come back later in the project and re-drill it, and that cost me a lot of grief. Um, we'll discuss a little more when we get to that point, but nonetheless, this piece got drilled out as far as I could drill it out with the drill, and then when it got cut and had to get turned around the lathe, it got drilled from the other side too. But for most of this, it was supposed to be drilled to the minimum diameter of that screw that went in, so the spring could sit in underneath the screw and on top of the plunger. And I did not do that. You can see right here where this is what I'm drilling it to, and where that tape is on that drill is just not far enough at all. So I don't know what I was thinking about at that point in time, but obviously I wasn't really thinking. Nonetheless, at the end of the day, it did involve a lot more work, but it did work. And you can see I got the piece marked out here for, roughly what I got to cut it. There's no huge tolerances that got to hit on the outside of this thing. It could be 3 inches, it could be 3 inches a quarter. It doesn't really matter, as long as the holes on the inside allow for the clearance. So once I got it drilled out, I come back in here with a tap, and I'm going to tap the top of this so the screw will fit in there. And my idea for this, and I've seen some of these made where they screw apart in the center, and I thought, why not put the screw on the end? That way you can, put the spring in there and use that screw to give it a little more tension if need be. So if your spring wasn't long enough, or the spring was a little bit weak, you just tighten that screw on the end in, and it'd be good. So I thought it was a brilliant idea, and just as I was finishing this project, I actually watched a Joe Pye show on using like a tap center and wrench or whatever on his lathe, and he was showing why you wouldn't do it, and how that just will wobble in there and give you the same effect of not having anything. So I realized it might have been a bright idea, but it wasn't mine. So nonetheless, it did work out good at the end, though. And now it's just, a matter of, starting to take this down with the most material possible. And I pretty much got it to size here. So I'm just, after doing a little bit of filing, and just going to take it down with the sand and paper. Originally, I was, planning on taking this down to half inch, so it would actually fit in a Jacob's chuck. But I thought, no, that's way too small, and I could have cut, just the end of it down to a half inch. But I decided just to leave the whole thing at the same diameter, and put it in a collet, and I'm quite happy with that decision. For this, I got the parting tool on there, but I'm just going to use it as a groover. I got to taper that front end. Well, you don't have to taper the front end, but I'm going to taper that front end, so it has a nice point for that pin to sit in, or protrude through, or whatever, like every other one of these things is. It looks pretty sharp, and I figured, yeah, if you're going to spend the time to make one of these, you might as well do it right. Because for the amount of time I got into this, I could have bought a dozen of these things. They're not the most expensive tool in the world, but hey, it's all about learning, right? It's not about throwing money out the door when you don't have to. If you got some material kicking around, why not? And this is a perfect job for going into that junk drawer for material and picking out some stuff you need. Unfortunately, most of my scrap stuff in my junk drawer is not of size, so I did have to use some new material on this. but it wasn't a lot of material. Maybe $4 or $5 worth of material and a lot of time. On my new this old knurling tool here, I was doing some reading for school, and explaining on setting on the centers and everything else, and the pressures that goes into it, and also that there was actually like two types of knurling, one which is actually cutting the material away, and the other which is displacing the material. And the type I'm doing right here is the type that displaces the material, so it's actually higher than the piece of material pre-knurling. And later on, that had to be taken into account when I remounted this in a collet. I had to come in from the backside, so not to try to force that knurling and flatten it in the collet itself. So right now, just put a couple lines on both sides and make it look pretty. And now it's just a matter of parting this thing off. And I think I'm running about 300 revolutions per minute here, and you can see the chips flying pretty good on this. And once I got used to it and not so timid from thinking that thing's going to chip the parting tool and shrapnel's going to go everywhere, which it could, but there's some fail safes you got to take, like keeping the oil in there. The thing has to be lubricated. If it's not, that's when it for sure bind. But just like that, done, parted right through. Then I turned it around in the 6 jaw truck, and I was just cleaning it a little bit up on the nose there. Um, then it's just a matter of it got counter drilled, and then the drill went in just to meet with the other side, so when that pin went in, it could go right through. Um, at this point, it's just a matter of taking some very, very light cuts to hit dimension on it. I've had lots of problems in the past on my lathe when I've had super thin material on there, and I'm trying to force too much of a cut. And of course, at this stage, I'm just using calipers. When it gets closer to where it should be finished, the calipers will go away and the micrometers will come out. And got the lathe file there, and just taking the first roughing cuts off with that lathe file. And like I said, I'm getting really sheepish about actually using my lathe on small, long stuff like that. And once that gets cut off, still going in with the calipers to see whereabouts we are. And I'd rather spend a little bit of extra time taking slight little cuts out of it than overshoot it and have to start all over again. Or worse yet, hit it with a tool on the lathe and have it bend. That's happened a few times, and it's very frustrating, when you got the time into one of these pieces and you got to start over again. But, it's all part of the learning process. So here, going down, about halfway down, it's to size. So at that point, I just take a marker and mark where I shouldn't be filing anymore, and just work a little bit off the front end to make sure it's also down to size, and then just taking some sandpaper after that and just cleaning a little bit. The file I'm using right now is a very fine file. It cuts beautiful on any metal I've ever had. It's just a matter of keeping it clean. And I can't remember where I got it, but I'd like to get a couple more of those. Not saying I'm going to wear this file out anytime soon, but it is a very nice file. And as you see there, I'm just so close to being on size. When I hit that with some sandpaper, it'll be perfect. It, as long as I don't stand it for 2 hours. I picked up some of this mesh paper. I really like it, but the traditional type of sandpaper works very well, um, especially on the coarser grades. When you get on the finer grit, and that it seems to clog. Running it wet, it helps quite a bit. So now I'm taking the part of the tool that it's supposed to be in and making sure that it fits right to the very bottom. It is a little snug on the very bottom, but it does fit. And this caused me some headaches at the end of this project, with that little part that we're going to be cut down here in the very near future. It just, no matter what I did, it seemed like the insides of that tool had a warp in it. It just did not want to slide properly in there with the dimensions that it should, fit within the thousands or 2000s. Now it's just a matter of cleaning it up a little bit with the sandpaper, and then we're going to go on to the very end there and get that to what I thought was the size. And like I say, I was going to the minimum thread diameter. And as soon as that's done, just part it off and taking it to the grinder here and just cleaning up the end. And I figured that'd be the end of that. And, just had to make a spring and put this thing all together. But this is where the problem started. And like I said, with this knurling, I had to put this back onto the lathe. So I put it into the backside so the knurling wouldn't actually go through the collet. And that worked perfect. And then the knurling didn't get damaged at all. And it it was nice and easy to get that piece in and out of there. Well, it was fairly tight, but nice and easy. Um, got a drill running through there now after I realized that it wasn't deep enough and everything else. And I probably ran that drill in there like 4 or 5 times, and I was still having problems getting that inner pin in there. It seemed like there was a little bit of a bend or a warp, and I think that's caused by the fact that I originally, just drilled the top half of that hole, and now there's a hole inside, and excuse me, I had to go back and re-drill the inside. So that's where I figured any issue was coming from was right there. But here's the solution. I had to dig out the reamers, and I marked my reamer off for how deep it should be going in there. And it did take out a little bit of material, not much, but when you're trying to get one metal rod slid inside of a tube, a little material could mean a lot. Okay, so making springs. I still really suck at making springs. Like I said the last time, I hope I never get tested on this. This one I actually made, it got thrown out as too small. So the next one I took, and I didn't have any video of it, but the next one I just took it like a 2.5 inch nail and put it in my vise, and did the same kind of application here where a vice grip was holding the music wire, and just wrapped it around. And when it started coming forward, I put a nut on it and pushed it back down. Well, you can see the spring there. It's not that great of a spring whatsoever. And you can also see that I actually got to push that through. So there still is some part in there that's a little bit too tight. But the nice thing is this still works fantastic. Um, so that part that is tight, the plunger actually doesn't even come up past that, and it doesn't affect its use whatsoever. So it's just a matter, getting that top screw in there, putting a little bit of pressure on that spring to where I want it. And I've had it in there before. I've already tested this, and cranked it up with the Allen key to see whereabouts I wanted it, and there it is, springs back and forth. So the only thing from this point forward is to put it in the milling machine and see if it actually works. And of course, my milling machine is still missing the motor, as I mentioned earlier. But there it is, and I got a little chunk of aluminum under there that I drilled out for this, and the tap follower is just doing what it's supposed to do, and that tap threaded in there really nicely. And that's the end of this project. I hope to get the motor back soon for my milling machine, because I'm really looking forward to building that toolmaker's vise that I had part of a video up there on, you know, metal prep for it. Anyways, that's it.